Hello, and on behalf of the Valerius Vampires, I welcome you to AVO, the interactive avocado value optimizer. So our group chose the dataset Avocado Prices, containing information regarding the sale of Hass avocados throughout the nation from January 2015 to November 2020 throughout the United States. For each recorded date of the sales to distributors across the nation, the average price, total volume sold, total number of bags of each type sold, and the region were provided. At first, we chose this data set because it would allow us to have a lot of flexibility to make visualizations and machine learning models. But as we went on, it became clear that this would help solve an issue that is much more dire. This issue is called food waste. In fact, recent statistics have gone on to show that 80 out of the 81,000 tons of avocados produced in just one location, Kenya, around 30,000 to 40,000 have gone to waste. Our product will generalize the price of avocados, ensuring that the most efficient price is placed upon this commodity, hereby reducing the amount of avocados that rot away in stores and warehouses, unused and unbought. And this is our data set that you can see. We got a data set that has over 18,000 rows to provide us with sufficient information to create evaluations.
The goal of our project, AVO, is to learn from past data and trends to accurately predict avocado prices. AVO will help sellers, manufacturers, and consumers all around. Sellers in particular will be able to identify the optimal price for avocados and maximize their exports, and consumers will benefit from locating the cheapest areas to purchase avocados. Some brief observations of our data include that the price of an avocado usually sell between 44 cents and $3.25, with an overall average price around $1.40. There was also a mean of 850,000 avocados sold in each region. And lastly, the region that sold the most avocados was the West, selling an average of 3.2 million avocados each day.
We analyzed the following heat map and tried to choose factors that had high correlation with each other. However, the average price had a weak correlation with almost all of the factors. And for this reason, we decided to choose it to make evaluations based on it, because the average price is possibly the most important factor out of all of the factors.
So to demonstrate the average price and model it over time, we used a line graph. With this line graph, we were able to visualize the pricing of avocados throughout the years. This helped see the fluctuation of pricing as well as the general increase in trends and variance over time. It can be seen that the prices often vary, but there is a general increase in prices over time.
And also, using a bar chart with long formatted data, we track the amount of bags of avocados that each region in the US acquired per year, and we were able to identify a significant increase in demand for avocados over those time periods.
In addition, using a bubble plot in a group data set, we were able to identify the price ranges in which companies sold the most number of bags of produce. As you can see, when avocados are priced around 70 cents to $1, the companies sold the greatest amount of produce. This information can then be used by corporations to make evaluations based on the on the price that they should place upon avocados. Next up is our machine learning models. Each of the members of our group created our own models and used our own creativity to generate the model that we thought would be best fit for each of the data sets.
All right, so for my model, I created an LSTM neural network, and I wanted to be able to predict the prices of the avocado in a given state. I picked a specific state instead of the nation because prices often change from state to state, but this can be changed just by altering the data set. In this specific model, I looked for California. So I used the LSTM model to predict the prices in California for the next month. I first modified the data set so it only reflects the avocado prices in California. Using that data from the previous 30 days, I used a look back of 30 for my neural network to then predict the prices for the next 30 days. I had a training set of 60% and a testing of 40. So that the testing could be better visualized on the graph itself. And the training set is represented in orange, and the testing is represented in green. If you can see, the blue is the actual price, and I used that to compare how accurate my prediction was and was able to correctly predict the fluctuation of prices.
I created an XGBoost regression model for our avocado dataset, and each branch of my tree represents a region or location and possesses a leaf containing the prediction for the prices of avocados for that specific region, whether the price will be greater than $1 or less than $1. Essentially, it takes the average prices of all avocados in that specific region and price range and outputs its prediction based on the data. As of right now, I have cut it down to include only regions that have prices less than 50 cents an avocado, and otherwise the graph would have just been way too large. And once it makes that prediction for a region, it moves on to the next branch or region and repeats the process.
Brent was actually the one who implemented this model, but unfortunately he couldn't come here today. So linear regression is a simple model that takes in data points and generates a line that best fits the data. It can take multiple factors into consideration when creating a line. Brent used linear regression to take both total volume and data into consideration when predicting the price. Brent also used linear regression to individually compare data to average price and total volumes to the average price. The three-dimensional graph below shows the predicted prices of avocados generally by Brent's model after taking in test data points. The two-dimensional graph below individually compare total volume and date to average prices. Random forest uses bagging to create an uncorrelated forest of decision trees and combining the results for a more accurate result. Here, a random forest regression model was implemented to predict prices of both organic and conventional avocados throughout the United States from 2021 to 2025. The model was trained with dates and average prices of avocado sales from each region from January 2015 to November 2022.
Similar to Jefferson, in order to effectively analyze our avocado dataset, I also used the random forest regression model, which uses an ensemble bagging learning method. First invented in 2001, this machine learning model consists of a series of decision trees that are connected in a way so that the end prediction is less prone to overfitting. The aspect of the dataset that I was specifically focused on was the average price of the avocados. I came to the conclusion that the columns that had the greatest correlation to the average price was the date and the total volume. Using the total volume and date as X values and the average price as a Y value, I put this data through my random forest regression model and create a few visualizations to represent the data. Now, as you can see, the first model that I've created is a 3D scatter plot, which correlates the date and the total volume to the average price of the avocados. And then the color scale is a continuous color scale, which also shows the accuracy of each of the evaluations made by the model. The colors, all the points that you see that are closer to purple are the ones that are more accurate. They have an RMSE or root mean square error of almost 0, and the ones that are yellow are the ones that are the least accurate. Now, as you can see, almost all of the data points are close to 0. And this is also exemplified in the second model, which is basically a scatter plot which correlates the actual value of the data of the predictions to the predictions themselves. And almost all of the scatter points are close to the line X is equal to Y. So almost all of them are relatively accurate. And this third one is just a small subset of what the decision trees in random forest actually are, just one small aspect of it.
Logistic regression is a classification algorithm that predicts a binary output, basically yes or no, based on previous data. I created a logistic regression model that predicted whether the prices of avocados were greater or less than $1.25. The x-axis is the date spaced out in weeks, and 0 on the y-axis stands for the price being less than $1.25, and 1 stands for the price being greater than $1.25. I also created a polynomial regression model, which is basically where you fit a polynomial function to the data. Again, the x-axis is the date and the y-axis is the price.
From analyzing our models, we discovered that avocado prices usually rise from the start of spring to midsummer. We also discovered that the coastal areas, especially the west of the United States, usually had the highest prices of avocados. Our models also show that increasing the number of avocados sold decreases the price of avocados, displaying a correlation between price and volume sold. Lastly, as time goes on, prices slightly increase, probably due to inflation, and are likely to remain above $1.25. In the process, we used several different models mentioned prior, but there was one model that performed distinctly well compared to the others. Using the RMSE to calculate efficiently, we found that the LSTM neural network model had an RMSE of almost 0.11, which was 0.15 higher than the next closest model. In the future, we will utilize the information that we have to produce an interactive web page in which corporations can access and use our best performing LSTM model to better run their companies.
Okay, I want to shout out to all the members in my team. We have Sean, Amogh, Bhavya, Brent, Aliana, and Jefferson. Thank you for your effort and collaboration. I was so impressed that you can complete such a wonderful portfolio in 3 weeks. Thank you all.